All right, ladies and gentlemen, we are working with Pythagorean Theorem. So when we are talking about the Pythagorean Theorem, we are talking about a squared plus b squared equals c squared. Pythagorean Theorem is something that works with a right triangle and right triangle only. So when we have a right triangle, we have to have a 90-degree angle within that triangle. Our long side is C. It's the hypotenuse. And then we have our legs. And it doesn't matter if I call that one A or B and this one A or B. But one of them is A, one of them is B. And Pythagorean Theorem tells us that when we do A squared plus B squared, it equals C squared. So if we have two of the sides, then we can figure out what the third side would be. So we're going to go ahead and we're going to work through a couple of these this evening. So if we look at number 1, we are looking for the C. That's the piece that we don't know. We don't know what the hypotenuse equals. So I know that I need to go A squared plus B squared equals C squared. Well, I'm going to say that this one is A, and I'm going to say that this side is B. So I know that 3 squared plus 6 squared equals C squared. I'm going to work it out and I'm going to solve it. 3 squared, 3 times 3 is 9. 6 squared, 6 times 6 is 36 equals C squared. 9 plus 36, that's going to give me 45 equals C squared. Well, I know that 45 is not going to come out as a perfect square, but if I take the square root of 45, then that is going to tell me what C equals. Now, looking at the directions tells me to round to the nearest tenth. So when I use my calculator and I put in square root of 45 equals, I hit my double arrows to get my answer, that's going to tell me that square root of 45 is 6 point, it's going to round to 6.7. So that would be the answer for number 1. Okay. Now, let's go ahead and let's look at number 3, because your assignment is 1 through 19 odd. So if we look at number 3, getting it set up for you, A squared plus B squared equals C squared. Well, we don't know what C is. We have to figure it out. I'm going to call this side A. I'm going to call this side B. So that tells me 4 squared plus 6 squared equals C squared. Now that problem is set up. You're going to go ahead and finish it up. Number 5, doing it totally on your own. When we look at number 7, with number 7, well, here is my hypotenuse, 13.4, so that's C. Well, I'm going to call this A, and I'm going to call this B, and B is the one that we are looking for. Okay, well, before I even worry about that one, if I take our equation, A squared plus B squared equals C squared. Well, B squared is what I'm looking for. Well, if I go minus A squared, well, that's going to leave me with B squared equals C squared minus A squared. So I've taken the Pythagorean theorem and I've reorganized it, and so I'm going to use that to help me with number 7. So if I have B squared equals C squared minus A squared. Well, I know that C squared, 13.4 squared minus 8.7 squared is all going to give me B squared. Okay, when I use my calculator, because I'm having to square with decimals, that's going to be 179.56 minus 8.7 squared is 75.69 equals b squared. Well, when I take 179.56 minus 75.69, that gives me 103.87. Well, I'm still not there yet. I need b. So I know that b is going to equal the square root of 103.87. Now that is not going to come out with a perfect square. I know that I'm going to have a lot of decimals. So I'm going to end up rounding. So when I take the square root of 103.87, then I find out that b equals 10 point, I'm rounding to the nearest tenth, so I'm not going to go 1, I'm going to go 10.2, because it's going to round up to 2. So that lets us know what 7 would be. So we know that the side B is 10.2. Okay, let's look at number 11. So the bottom part, we're doing the same thing, it just didn't give us the triangle. It's just telling us what the side lengths are. So I'm still using my Pythagorean theorem. So, but on on number 11, I don't know A. That's what we've got to figure out. So if I am trying to figure out one of the legs, I need to do c squared minus a leg equals the missing leg. Okay, so 37.3 squared minus b is 10.2 squared, and that's going to give me a squared. Okay, I'm going to use my calculator to figure that out. So this is going to be 1391.29 minus 10.2 squared, 104.04. It's going to give me a squared. So, doing that subtraction, I get 1287.25 equals a squared. Need to do the square root. Square root of 1287.25 equals a. So when I do that, I know that a equals 35.9. It's 35.87, but it's going to round to 35.9. Okay, so that is number 11. Let's look at number 12. Number 12, also now we're looking for b. So I'm going to go c squared minus a squared equals b squared. Okay, so taking it and setting it up. C squared, 38.7 squared, minus a squared is 23.9 squared, and that equals b squared. So now it's set up. You're going to finish and you're going to solve that one. Now, one more that we're going to look at together. Let's go ahead and look at number 17. So when I look at 17, we're looking for the hypotenuse, looking for c. So a squared plus b squared equals c squared. A is 20.3. We've got to square it. B is 41.6. Also got to square it. Equals c squared. Now we do the math. 20.3 squared is going to give us 412.09 plus 41.6 squared is 1730.56 equals c squared. Now, doing the math, we've got to combine those two answers. So we combine them and we get 2,142.65 equals c squared. Now, to solve it, we've got to do the opposite of squaring. We've got to do the square root. So c equals the square root, 2,142.65. So we've got to do the square root of all of that. And when we do that, we get 46.28, which is going to round up to 46.3. Okay, and then you're going to finish up number 19, and then you are all done.